Hey Nano fam, hey, how are you? Hey YouTube. Welcome to the third edition of the RS Nano livestream. And yeah, I'm excited what will happen today because I actually don't know. I have not prepared anything. So this stream will be, I don't know what's going to happen. I think we will just continue where we left off last time. That means we are going to work on the backlog population class, maybe even finish it, like port all of the class. And of course there will be the 5 nano giveaway. And yeah, let's read the chat. Because Average Squares asked how you could participate. Hi Jan, hey, nice that you're back. Oh yeah, so Jan, you suggested that I would stream on Twitch, and I think you're right. I had a look, and Twitch is just the better platform, or the more popular platform, and I'm going to stream on Twitch starting next Monday. I couldn't manage to get stream and YouTube to work in parallel today, but starting from next Monday, I'm going to stream on both YouTube and on Twitch. I think that is a good idea. So, hi Johnny, hi Guillermo, oh, you're back too. Okay, so the giveaway this time, I thought we will try something else, something also a bit more fun. And instead of just picking a winner by random, I thought we could do a quiz where I would ask one question, and it won't be a hard question, I think. So you say any of you could answer it, and the first one who posts the correct answer gets the 5 nano. What do you think? Average Square said I don't have Twitch. Oh, you don't have to. So I'm going to stream on YouTube and on Twitch at the same time. Okay. Did I get all chat messages? Hi, Johnny. Yeah, so just out of curiosity, are any viewers not from the Nano communities? Are there any viewers that are only interested in Rust programming, or only interested in how to port C++ to Rust? Johnny says, good idea. Guillermo says, that's okay. Jan says, unless the answer won't be BitGrail, it's fine. No, the answer won't be BitGrail. Average Square says, yes, love quizzes. Okay, yeah, it will be very simple. Just one question, and yeah, the fastest one of you will get the 5 nanos. Okay, so as I said last time, I'm going to stream every Monday the same time. So just let's switch to this. Yeah, so you can see it. Yeah, every Monday, 8:30 London time. As long as it's fun, and it is fun still. So I think I will do this for quite a bit. Okay. Yeah, so let's get started. So for all the new viewers here, this stream is about the RS Nano project, and we are porting the Nano cryptocurrency node from C++ to Rust. And rsnano.com is the website of this project, and there you can see the progress. So we currently have very roughly 1/3 of the node ported to Rust already, and we have ported all the easy parts, and all that's left now is the hard stuff. And let's see how well that goes. It's an open source project. You can find the source code on GitHub. My name is Simpago on GitHub, and yeah, you can find everything there. Johnny says, I'm into Nano, but know almost nothing about coding. Oh, that's cool. So yeah, of course we will code a lot in the stream, but if you like, we can also like talk about Nano. So if you have any questions or want to discuss whatever, just write it in chat. Average Square says, I just subscribed you. Oh, thanks. That's great. Johnny says, but I think this project is so cool. Yeah, I started this project just as a hobby because I wanted to do it. I loved Rust and I loved Nano, and I thought maybe I would spend a couple of hours a week on this, and now it just I spend like a lot of time on this now. Wenderson says it is better than watch series in the HBO. Really? Really? I don't think so. but I'm happy that you see it like that. Okay. Yeah, so for the giveaway, I wanted to say, so if you don't know how to get your Nano address, just download Natrium. It's a very beginner-friendly app. And once you installed it, you can click on receive, and then you can see your Nano address. Okay, so let's go to switch to Visual Studio Code. Last time we ported a method in here, and the method was activate, and we finished that. So if we have a look at activate, it does only contain one line now, and that is the call into the Rust part. And so my idea was to just have a look at this class and try to port the remainder of this. And last time I actually had a look at the code, like and I knew what I wanted to do, but this time I have no idea. So this stream will be maybe a bit slower in pace, and I'm going to run the tests and actually compile, so we will have more time to talk. Okay, let's go. Okay, so we have the activate method. So maybe we could start by something very simple, because this activate method is not being used at the moment, or it's just being used in one place, and that's in this method above, populate backlog. So yeah, let's just start with something very simple, and that is just inline our FFI function call into these other methods here. So we could just do it like this, and account, and we could remove this, and then we could remove this activate method down there, and we could remove it from the header file. Okay, so let's have a look at the method populate backlog. Are we able to bring this over to Rust? There's a config field that we don't have in the Rust yet. Let's have a look at the Rust code. So this is the Rust code for the backlog population. And we have the ledger, we have stats, we have the activate callback already. So we do have to move the config field over. And there's a stopped. What is stopped? Stopped is just a Boolean. And done is also just a Boolean. So, oh, okay, this is not a field, this is a local variable. Okay, we have to move that one over. Okay. And this takes a unique lock as an argument. Oh, a unique lock. So, okay. I don't want to wrap the unique lock, because that's just, I think this is just a lot of unnecessary work. Like writing a wrapper for the locking stuff. Ugh, we would be busy quite a while, and I think our best guess, our best approach would be to just port all of it at once, because this is just such a small class, and these helper functions, the callback wrappers that we wrote last time, we don't need to port that. So let me move that to the top. So this is on the top now. We don't have to move this. So these are helper functions for wrapping. Activate callback. Okay. So, by the way, do you guys have any idea what else we could do in the stream? What we could show, what we could talk about, so that it's not like a stream that does focus on coding all of the time. Do you have good ideas? Okay, so we have start, which starts a thread. We have stop, which stops the thread. We have trigger, which calls notify, which calls a condition variable, and that, I guess, notifies the thread to do something. Predicate. Yeah, so this triggers the thread to, yeah, to actually do something. It takes a lock. Okay, so here's the plan. First, I'm going to move the config field over to Rust, because we need that, and then I'm going to port this method, and I'm going to port it without it being used, just so that we have the code over at Rust. And then after that, I'm going to port the run and the trigger and notify methods, because they are very simple. And then we can just switch to the Rust version and run the tests, and hopefully everything still is green. Okay, so let me copy this code here, the populate backlog method. So copy, and let's go to the Rust implementation, and let's paste that code here. And because this is C++, let's comment it out. Okay. And now we can start by translating line by line. So it will it be pop? Probably not. So this is a function, and it's called populate backlog, and it takes self, and it takes a lock, unique lock. I'm not sure how this should look like in Rust. So what would be the lock? Would this be a mutex guard? What happens with this lock? Let's have a look. There's an unlock, and then there's a relock. That's strange. Where else is this lock being used? So up in the run method, we create the lock. Then we pass it to the populate backlog. And then we use it down here in the condition.wait. And let's have a look at how Rust handles this, because I know in Rust there's also a cont var, which is the same thing. And we want to use that one. So this also has a wait. And this takes, yeah, it takes a mutex guard. Jan says, commented out, C++ is the best C++. Yeah, I agree. Yeah, C++ is so, yeah, such a pain to work with once you worked with Rust. Johnny says, I read the info on the Ars Nano page, but could you explain a bit more? Like, can this somehow run together with Nano, or does it have to be a new coin? And will it be faster, slower, or the same? Oh, great question. Thank you for the question, Johnny. Okay, so this is not a new coin. Well, people could use it to create forks, of course, but the goal of this is to have a nano node, a working nano node, and it would do exactly the same thing as the C++ nano node. And I hope to make it really, really fast, because not because Rust would be faster than C++. C++ is incredibly fast, but Rust allows us to refactor like fearlessly. So it allows us to make changes that I would not make in the C++ code base, just because C++ is incredibly hard to work with. And yeah, just making big refactorings in such a hard language, yeah, this is a nightmare. And Rust, with all of these compile time checks, it allows for doing these big refactorings a lot easier. So yeah, right now Ars Nano is not faster. It's actually like Gravity made. So Bob, or Gravity, he tested it and he found that it was like 20% slower right now. And that is to be expected, because the glue layer that connects the C++ and the Rust part, that glue layer, it drains performance, because there's a lot of heap allocations there, a lot of copying of that data, and that layer is temporary. And once we have translated everything to Rust, that glue layer will be deleted. And at that point, I hope that it is just as fast as the C++ version. And for the future, I want to improve performance, as I said, by doing bigger refactorings. Okay, I hope that answered your question. Populate backlog. Jan says, in the end, it should be a node implementation compatible, at least on the protocol level, right? Yes, it should be 100% compatible. So it should not matter if you run a node with the Rust version or the C++ version. And so this, as I said last time, this is my goal for this year, to switch my principal rep to the Rust version. But for that, I want to wait. There's this ascending bootstrapper currently in development, or the development has finished. It is being tested, and that just improves bootstrapping a lot, so that that you can just bring up a new node and bootstrap the whole ledger and not having to wait forever. And once that is is live or is tested and I could use it, then I wanna bootstrap a node with the Rust version. Okay. Lock. Okay, so I was thinking about the lock and how to pass the lock to the populate backlog function, and the mutex guard requires the cond var requires the lock as a mutex, just a mutex guard, and it consumes it. I would love to give, instead of a lock, I would just love to have a mutex. Would that be possible? Because that would simplify things. If we just get the mutex here, let's check who calls the populate backlog. Just this line just here. And we have the lock up here. What does this lock protect actually? Let's see. Predicate. So triggered is. So I think this lock is for the triggered boolean and for the stopped. For the stopped boolean. If we just pass. Well, the mutex is a field anyway, so maybe we don't have to pass anything. So I'm currently thinking about whether it would break the code if we would release the lock here and reacquire the lock inside the populate backlog function. Because I don't think we can port it as it is, because we would have to pass the lock by reference, and then we can't unlock and lock it, because that's just not possible with the mutex guards, I think. But maybe we could return. Maybe we could return a mutex guard. We could take a mutex guard and return a mutex guard. Average Squares asks, can you use ChatGPT to code this? I tried ChatGPT and it's incredible what it can do. So this it's astonishing. But I think it only works on small, simple problems, and so you couldn't just say, ChatGPT, could you port Nano to Rust for me? And so this is I think it's helpful for understanding code, or maybe even porting small functions, or writing, I don't know, scripts or whatever. But I don't think you could use it to port bigger things yet. Who knows what's going to come, what will come. Okay, let's go back to this lock. So I could, what did I say? I could cannot pass a mutex guard and return a mutex guard, so I mean taking ownership here. Does the mutex guard, it has a lifetime. I don't think this will work, but I'm going to try it anyways. So we could take a mutex guard, what does this take? So T and a lifetime, and it will return a mutex card. With the lifetime. This would be simpler if we would release the lock here and relock inside the populate backlog. We have to be just very, very careful to not introduce bugs, because this is this would change the behavior a little bit. And not sure if this is safe. Who else locks the mutex? The trigger. The trigger sets trigger to true. And we check for the triggered field in the predicate. And we call the predicate here and here. Condition. And who calls condition? Notify all is called in notify. And after the trigger. This looks safe to me. I think we could do it like this. I think we could release the lock here. Okay, we could experiment. So let me just comment this out too. And I want to just run the tests. So these tests, this is not a 100% guarantee that it is not a bug, but if it is a bug and maybe the tests would find it, then we would know immediately. So let me just as an experiment unlock the lock here, and let me relock. Yeah, this of course this will work. So I don't see a reason for this not to work. If we unlock it here and we just relock. If we just relock here. So if we port it like that, we could just use the mutex. We could just use the mutex in the populate backlog. So I'm going to compile this and run the tests quickly. Oh, I forgot to limit the compilation threads. Let me just do this quickly. CMake. Because I don't want to, because streaming takes a bit of my CPU, I don't want to use all of my cores for compilation. What was the jobs? So parallel jobs? Yeah. I want to just use 3 cores. Okay. Yeah, let's compile. And while this compiles, let's use that time to to port it just by using the mutex directly and by not bypassing around mutex guards. So let's not pass around mutex guards. Let's not return mutex guards. We just take nothing. Like this, and down there. Okay, so we have a debug assert. Oh, the config field. I forgot. I wanted to port the config field. Yeah, let's get the config field over to Rust first. What is config? It is a struct with a bool, unsigned, unsigned. Oh, that's good, because I could show you the second strategy that I use to get stuff from C++ to Rust. So usually I heap allocate and use handles like we did in the last stream. But this time, because this is just a bool and two unsigned fields, we could just use a DTO, a data transfer object. Just a simple struct that would directly contain all the data in a C compatible way, and we would pass everything by value. So backblock population config. So let me copy this and let me bring this over to the Rust side. And this would be abstract backlog population config. And it would have an enabled as a bool, and it would have a batch size as a U32, and it would have a frequency of U32. Oh, and this has to be a comma. So, enable control. I just want to read the comments quickly so that I know what this does. Enabled says control if ongoing backlog population is enabled. If not, backlog population can still be triggered by RPC. Okay. The batch size is number of accounts per second to process. Number of accounts per single batch is this value divided by frequency. Number of accounts per single batch. Frequency, number of batches to run per second. Okay, batches run in 1 second per frequency intervals. Okay. So the backlog population requires us to have a field called config, and we take it we get it by the constructor. Yes, yeah, config. So the constructor takes a config argument. So let's do the same in Rust. Let's add config. Is we take ownership of this, because this configuration it won't be changed during the runtime of the program. So let's initialize the field like this. There's an error here. Missing field config in initialize of backlog population. Missing config. Why is it missing? Wait. Again. Okay, wasn't an error. Okay. Still building. Okay. So, but now we have, let's jump through the errors. Yeah, so in the FFI side, we expect the config argument here. But we don't have it yet. So now here's a thing that I usually do, and this is just to have a very strict separation in the code base of what is FFI, so what is the glue code between C++ and Rust, and what is our implementation. And I could use the backlog config struct directly, I guess, but I just don't want to, just to have a very, very strict separation here. So I want to duplicate this. Let me copy that, and let me just paste that struct here, and I want to give this the name DTO. So this looks like code duplication, and it is, of course, it is duplication. But this gives us an advantage, and the advantage is that we could refactor the Rust part, so the real backlog configuration backlog population config. We could refactor this on the Rust side, and we would not have to worry about the FFI bindings. So we could use our own domain types instead of primitive types. So instead of U32, we could later introduce whatever types, and we could just refactor and keep the code clean, and we would not be limited. We would not have to make sure that this config is C compatible. So so that's why I usually copy these structs into the FFI layer. So Piotr, hey Piotr, you're here too. Nice to see you. Good spot on that unnecessary log passing. It is not needed and really shouldn't be held while the thread is sleeping. Oh, that's good. Oh, Piotr, you're helping me out here. Great. By the way, so guys, if you don't know Piotr, he is from the core team, and he's a really good programmer. I'm a huge fan of your work, Piotr, so shout out to you. So this is, that's good to hear. It's not really, it shouldn't be held while the thread is sleeping. Yeah, that was something that I found really odd. Like we lock and then we sleep. So we have a long held lock, and that's usually a bad idea. But my plan is to first port it as it is, and then maybe we find a more elegant solution for this. Okay, so we have the DTO, and in our RSN backlog population create function, we have to add the config DTO. So config DTO is going to be it can be a const pointer because we don't change anything there. So it will be a const pointer of backlog population config DTO. And this won't work yet because we have to say that this DTO is a C struct. So we have to say wrapper C, which tells the compiler to treat this as a C with a C layout, so that we can use it. And now we have to convert the DTO to the real config, and let's just implement the from trait for this, so that we can say config. So dereferencing the raw pointer, and then we can say .into. So let's implement this, impl from backlog population config DTO for backlog population config. Oh, backlog population config isn't public yet. Now it is public. Back to the FFI part. So we are currently writing a converter that converts the DTO to our actual domain class or domain entity. There it is, config. Let's implement it, and we return. Basically, we just have to copy all values, all fields from the DTO to our config instance. So enabled. Batch size is value.batch size, and frequency is value.frequency. Okay, and this should. There's still an error here. Cannot find value config in the scope. Oh, I named it config DTO. Yeah, looks good. So we still have an error. Cannot move out of config DTO, which is behind the raw pointer, which does not implement the copy trait. Yeah, we could also make this a reference. Then we don't have to implement copy, but then we have to say the from trait is for references. So we convert a DTO reference into a backlog population config. Yeah, that fixes That fixes the error. And the build is done, has finished. Let's check. Yeah, finished. So while we work on here, I would like to run the tests in the background. So let me just run the test here and we check the results later. Okay. So we have the config field here. We have the config in the FFI part. And now we can add the config to the C++ constructor. So that is up here. We call rsn backblock population create. And this should now take, yeah, this now takes a pointer to backblock population config DTO. And the DTO, we have it here in the header file, which was automatically generated. So I have to move this down here because we have to create the DTO first before we can call the create function. So this will be an rs nano backlog population config DTO, and this we can pass into the function, this argument config DTO. So let's just assign all the values here. Config DTO enabled. Enable is config a.enable. Is that? No, oh, it was enabled. Why did it suggest enable then? Enabled is enabled. Then what's the other fields? Batch size, frequency. Batch size is batch size, and frequency is frequency. Yeah, that's it. There's still an error here. This comma has to go. And these warnings are the unused imports, so yeah, we can fix this later. Tests are still green. Good. Okay, so we have the config. We're done with moving the config to the Rust side. And that means we can now start here. And let's just port it line by line. So the first is a debug assert. We can just use that. Just leave it like this, debug assert config. So this would be a self.config, but frequency is bigger than 0. The next line is chunk size. So this calculates the chunk size const auto. So let's say let chunk size equal to self.config.batch size divided by self.config frequency. And the result is U32. Then we have a done, which is a boolean, and we have an account next. So let's say let next. This has to be mutable. Account is account 0. And we have a total. So the total is a U64. Probably has to be mutable too. U64. And now we have a while loop. So let's uncomment this and let's uncomment the curly braces. And it says while not stopped and not done. So stopped and done are both No, done is a local variable, but stopped is a field. So we have to add the stopped field to. Let's just check the header file in the C++ part. It has, where is it triggered? It has a stopped, yeah, just a stopped boolean, just false. And yeah, we can just do it the same way in the Rust part. So we can just add a stopped field. Stopped is a boolean, and we initialize that to false. So while not self.stopped and not done. So in Rust we don't need parentheses. Oh, is that, yeah, is that the English name for that thing? No, braces? No, braces are, yeah, parentheses. And okay, what are the next lines? So there's this lock.unlock. The lock protects the stopped field and the triggered field. So let's acquire the lock up here by saying self.mutex. Oh, we don't have a mutex yet. Lock unwrap. So we have to add the mutex first. And what type of mutex, or what does it protect? So this is a fantastic design decision by Rust, because as you can see in C++, there is the mutex. Where is it? Here, and it just is here, and it doesn't tell us what is protected by this mutex. So we as developers have to know, and we have to make sure that we don't make mistakes here. And in Rust it is different. In Rust we have to tell, or in Rust the protected data lives inside the mutex. So in this case it would be the stopped bool and the triggered bool, yeah. Triggered bool and the stopped bool. These are protected by the mutex. So in Rust we have to translate this a bit differently now. So we have to give a data structure here that contains the stopped and the triggered. So we could do it like this, like a pair of bools, but I don't like that because it's just it doesn't make sense for a new developer, because he just sees two booleans and he doesn't know what it means, and it won't make sense to me in 2 months, because I would have forgotten that too, what this means. So let's just create a struct for this with two boolean fields, which is stopped and triggered. And we need a name for the struct. What would be a good name? Do you have an idea, chat? What would be a good name for this? I'm going to pick a bad name, and we can improve that later. So the bad name would be backlog population stopped flags. Flags? I don't like that. And so now we can use this in the mutex. So the mutex protects an instance of backlog population flags. And so let's change the constructor down there, the new method. So mutex will be a new mutex, and the mutex takes a backlog population flags, where stopped is false and triggered is false. Let me quickly check if triggered is false in the beginning. Yes, triggered is false in the C++ part. Okay. Reformat the code. Yeah. And so that means down here we lock our mutex. And then we can check the stopped flag by saying lock dot stopped. So this is now the difference I was talking about. So if we want to access fields that are protected by mutex in Rust, we have to go through the lock. So it is impossible to access a field that is protected by a mutex. So it's impossible to forget to lock the mutex because you just can't write the code in that way. So we have the lock here. And the first thing in the while loop is that the lock is dropped. So we can do that in Rust too. We say we just drop our lock. Oh, there's what's borrow of moved value lock borrow. Oh yeah, because I dropped it. So it is dropped here. And down here we reacquire the lock. So we can do this by saying lock is self.mutex.lock. And this has to be mutable. The lock has to be mutable because we reassign it down there. That's correct. Okay. So we have a code block here. And this starts a transaction. We can do that too, like that transaction is let's just store tx begin read. This returns a result. That's a design decision that I made, and I want to revert this soon, but I don't want to return results for this because this just should never fail. And if this fails, so if starting a transaction fails, I think something went horribly wrong and we should just abort the program. So I'm going to change this in the future so that tx begin read does not return a result. Okay, because otherwise we have to check the result every time we start a transaction. Or we write unwrap like I did here, and that's also not nice. Okay, so we have the transaction. And we have a count, which is 0u32. Then we have an iterator over the account store, which, let's see if we can just translate it on just as it is. So this is also self ledger store account begin. It takes the transaction and next. And next is... What was next? Count? Yeah. Next, as a reference. No, what does it take? Oh, so this is something that I'm unhappy with Rust. You can't overload functions. So if we have, like in the C++ code, there's multiple overloads of the begin method, and so this one just takes a transaction and another takes a transaction and an account, and in Rust we have to give that function two different names for that, and so that's why I called this one begin account. So we have to call begin account, and this returns an iterator. This gets the end iterator, but I think we can write this in a different way, which does not require the end iterator. So what does the for loop do here? So this does... Can we write this as a while loop. Let's see, while the iterator should not be the end, so we can check this with isEnd. While the iterator is not the end and count is less than chunk size, and in the at the end of the loop we have to increment I. So this is the next method. What does next return? Oh, it returns nothing. It just moves the iterator. So this is not idiomatic Rust at all. I ported the iterators as they are, or mostly as they are. And my plan is to use them and or leave them like that until everything is ported, and then I'm free to change the iterators to be more Rust idiomatic. So we increment the iterator, we increment the count. So that means count has to be mutable. And we increment the total. Yes, total is already mutable. So that is this for statement. I, count, and total. And why is there a problem here? Because it is, this iterator has to be mutable. Okay. So that is this line. And these lines belong here. So what do we do here? We increment the stats. Yeah, we should be able to do that easily. So self.stats. Inc. Stat type backlog. Detail type. What was the detail type? Total. And let's ignore the result, because if there is a problem there, what should we do? Like, these stats are only being used for debugging as far as I know. So the account is let account. So we take the account from the iterator, and the iterator, how can we access the current value with current? Average Squares says, did you check out the Valentine's Day Google Doodle? It's so cute. No, I didn't. Let's do that. What? Shouldn't this be up here? Oh. I can't see it. But it's not Valentine's Day in Germany yet. Which time zone are you in? Okay, let account. Account is so we access the current value, and this returns an option. But I don't want to. So we could just unwrap the option because we know there is one, because we checked that the iterator is not at the end up there. But there's a more idiomatic way for this. We could just say while let some account equal to i.current, and then we have to move these the second check inside, because while let statements don't allow us to use to check for other conditions. So if count is less than chunk size, we break. Break? To break the while loop. Okay. Is that correct? Just going back to the CPP to just have a look at the code again in the CPP version. Oh, and we have half past 8. So I would say it's time. It's time for the giveaway, guys. Okay. Are you ready for the quiz question? And the first to answer the question correctly gets the 5 nanos. So be quick and just write the correct answer in chat, and after that write your nano address in chat. Average Square says, why does the doodle link I sent gets deleted? I don't know. Maybe you are not allowed to send links in YouTube chat? I don't know. So, are you ready, guys? The question. Oh, I have to find the answer myself. One moment. Let's go here. Not telling you where I'm looking. I hope you can see. No, you can't see. No. Let's go here. Let's click on here and okay, the quiz question for the 5 nanos is this. Here it is. There was a video created that compared Nano's energy usage to the energy usage of Bitcoin, and it got popular on Reddit and on Twitter, and it showed it as the energy usage as a cube. And the question is, how many nano transactions, according to this video, how many nano transactions can you do with the same amount of energy that is required by only one Bitcoin transaction? That's the quiz question. How many nano transactions can you do with the same amount of energy that's required for one Bitcoin transaction, according to this video? So chat delay, we have a chat delay, let's wait. We have an answer. 3 million says average squares. Nope, that's not the right answer. Check again. So if you don't know the actions, quickly go to Reddit and find that video in the nano currency subreddit. Wenderson says 1,700. No, that's way too low. Nano is really efficient. Rusted says 16 million. Should we let this count? No. Okay, so there's, I want to have the number from the video, and the video is, it's close to 16 million, but it's not the number in the video. Gustav says, hey, oh, your name is Gustav too. That's funny. The 6 million, 6.6 million, no, that's not the number in the video. No more guesses? Okay, if there's no more guesses, then okay, no more guesses. Then Rusted, you're the winner, because you're really, really close. Oh no, okay, yeah, no, okay. I said it. I said it, Rusted, you're the winner. Okay, because I just saw that Jan posted the correct answer. But okay, but Jan, you won the 5 nanos last time, so this time it's Rusted. I hope it's okay for you. So let's have a look. Let's have a look at this video, and maybe I could just stop the music and So this is the video. I find this really impressive. So it says 15.5 million nano transactions for one Bitcoin transaction. Jan says, yes, I won the last time. Oh, fair. That's nice of you. Okay. So Rusted, post your nano address and I'll send you 5 nanos. So I'm opening up my wallet already. So let's go to my account. Yeah, there it is. Okay, let's copy that. And going to Nano Looker for the QR code. And let's send you 5 nanos. 5. And wait a second, where's the scan QR code? And just clicking on send, clicking on confirm, and my fingerprint, and done. Have fun with the 5 nanos. Okay. Okay. Wenderson says, very impressive, nano is the light. Yeah, so I haven't checked the math, if it's really correct, but if it is correct, like 16, almost 16 million transaction for only the same energy as one Bitcoin transaction, that's incredible. Average Square says, I just found that out from Nano Discord. Clever. Okay, let's continue. We added this if count is less than chunk size. Less than chunk size, does that make sense? No, it doesn't make, as long as count is less than chunk size. As long as it's less than chunk size, we want to continue. I thought that would make sense right now. We have to say if the count is bigger or equal to chunk size, then we want to stop the loop. Okay. Kurt says average squares, the calculation uses current TPS, so depending on the daily average, it varies a bit. Same goes for Bitcoin's energy usage. Waste, yeah. Yeah. So we are here. So we now have the account up here. We don't have to access it like down there. Jan says lol. Yeah. And then we have to call our activate function, and this is the function we ported in the last stream. So self.activate, and this requires the transaction. And no, not activate. Oh yeah, activate. And the account. And the account is, okay, that's why, because this is a pair of, a tuple of account and account info. So we have to say account, and we don't need the account info. So let's ignore the account info. So now we have an account. So let's delete this line. And next, so we say next is we increment the account number. How can I increment? Because let's just go to the account struct quickly to see how we could increment. Oh, I used macros for this. How could we increment this? we can convert it into a number and increment the number, and then we can convert the number back into an account. Yeah, that works. Let's do that like this. So we say account.number +1, and then we convert it back into an account. Do I have to worry about endianness here? Because this returns, oh, a CPP int backend. So this is, I think, big endian by default. And this, and when we add 1 here, and we convert it back into an account, what endianness is do we use there? Number? No, number. Lip. Where's the from? What? Average Square says Rusted is already a nano whale. 5 nano is like a drop in the ocean. Yeah. Okay. Wait a second. This is, wanted to have a look here. Count. No. Clicky. Big endian. So it converts it to big endian. I think this is correct because the C++ code also works in big endian. Okay, that looks good. I think this is correct. So we add 1, and this is the next account. And we have this done flag. Is this real? Was it like this in the C++? Part 2 that we have a done. Why is there this code block? Oh, this code block is here so that the transaction gets destroyed. Okay, makes sense. So that's why. And then we have the done and the done in the end. Okay. So let's set the done to, let's say done is ledger.self.ledger.store account begin transaction, and next begin account. Next is end. So we can just ask is end. So done is not mutable yet. Let's make it mutable. Reformatted the code. Begin account. Where was the other begin account? Up here. Okay, we can optimize this later. So usually I don't mix different types of work. So usually I port stuff as it is, and I don't change the structure in any way usually. And once it's ported and I have unit tests and everything, then I change the structure. So I don't worry about this maybe being inefficient or maybe the code being hard to read right now. I want to get it to Rust first, and then I clean it up. So this line here is the reacquiring of the lock. So can remove that. Then we have a comment here, give the rest of the node time to progress without holding database lock. Okay, so there's a sleep in here. So we can, how to sleep in Rust. How to sleep in Rust. Sleep. I have no idea. There's just a sleep function instead thread. Okay. Why didn't it show me? So sleep for milliseconds. So duration from duration or duration. Yes, duration from millis. 1000 divided by self.config.frequency. Yeah. Import sleep. Oh, this does not take, this does take a U64, so we have to convert the frequency, whatever, as U64. Yo, looks good so far. So we ported the populate backlog function. It says total is not used, and that is strange. This should be used. Let's have a look at the C++. Maybe code, maybe we forgot something. Wow, that's strange. It is not used. So the total is here and it is incremented up here, but it is never used. So maybe it was used in the past and now it's not used? Or is this because there's a total, so there's a stats total, but the increment for the total in the stats, it happens in the stats class. So maybe in the past it wasn't like that. I don't know. But total is not required. So we can delete this. We could delete this in the C++ part too. So let's delete the total in the Rust part. And we don't have to increment total then. Oh, by the way, I'm thirsty, guys. Where's the camera? Can I check? Oh, and don't worry, there's no beer in it. I don't drink and code. There's orange juice in it. I like this beer mug so much. Okay. Forrest, hey man, how are you? Awesome to see you stream, Gustav. My dev skills are maybe not good enough to understand exactly what you're doing, but I love it. Thanks, man. Thank you so much. Yeah, well, I want to make the stream not only for devs. I don't know how I can do this yet, so maybe you have good ideas. But I'm happy to see that people that are not devs are joining. Jan says, damn, I thought it was. Yeah. I like to drink a beer from time to time, but not, I can't. I just can't drink a beer and code. That doesn't work for me. Okay. Awesome nano mug, yeah. Yeah, like in the last stream I said I got this as a birthday present 2 years ago from my brother and his wife. So we ported the populate backlog function and this looks good. So let's go back to the C++ part. So, but we don't use it yet. So this time, like last time, I ported the function and I used it directly from C++, but now we don't use it yet because this is a bit difficult because of the mutex. So we don't. So we could work in the same way so that we could port function by function by function, but for that we would have to move the mutex to Rust, and then we would have to use the Rust mutex from C++, and that's just, so this is doable. I did this in the past, but it's just a lot of work, and I think we will make faster progress by just porting all functions at once, because it's just not much code. It's just a very small and very simple class, and then we don't have to bother using the mutex from C++, the Rust mutex from C++. So let's just move to the next one, to the run function. And when we have the run function, then I think we're almost done with this class. So let's copy the run function and bring this over to Rust. And that's commented out. Okay, so fn run, it takes self and nothing else. So let's see what we can do here. Then okay, this acquires a lock, so we can do that. Let lock equals self.mutex.lock.unwrap. So then we have a while loop again, while not stopped. While not stopped, and the stopped flag, we have to access the stop flag, as I said before, by going through the lock. So while not lock.stopped. If predicate, oh, we don't have the predicate function. Okay, let's go to the predicate function. It's up here. And this goes to triggered and config enabled. Okay. That's a very simple function. We can port this easily. So this returns a bool. It takes self and returns bool. And this requires the lock, because we have to access the triggered flag which is in the lock. It's a mutex guard. Nah, we don't even need a mutex guard. This has to be, can just be a reference to backlog population flags. And we return lock.triggered or self.config enabled. So now we have the predicate function. Okay, so if self.predicate, and we have to give the predicate our lock. So this is a bit different as in the C++ code. And then we increase the stats. Stat type is backlog. Detail type is loop. Okay. Then we set trigger to false. That means we have to say make them lock mutable, because now we change the flag. So let's say lock.triggered is false. And then we unlock the mutex, so drop lock. Then we call self.populate backlog. Yes. And now the last bit, condition.wait. So we need the convar condition. Condition convar. We have a convar, so we can say self.condition.wait. And what does wait take? It takes the mutex guard and returns a result mutex guard poison error. So we don't have to worry about this poisoning stuff. We are just going to assume that there are no bugs in here. So it takes the guard, which is the lock, and it returns a new lock. Oh no! Wait a second. This wait is actually with a condition here. So we have to. What else can we use? Wait timeout. Wait while. We have to use wait while. So wait while takes the lock and it takes the condition, which is a function that returns bool, I guess. And this condition is stopped. So stopped is... Oh, what is this condition? Let's go to the documentation again. Convar. Wait while. So f is a function that takes a mutable t, and t is the thing being protected by the mutex. Okay, that's good. So the t would be... Can I call this lock 2, or is this confusing? Nah, we shouldn't. This is confusing. Let's call it L. L dot stopped or self dot predicate L. And this returns a new lock. Yeah. So let's say lock is this dot unwrap. Wait while. Stopped or... Yeah, stopped. If it is stopped, we don't want to wait anymore. Or if the predicate is true, we don't want to wait anymore. And the predicate is true if it is triggered. Or config.enabled. Makes sense. So let's reformat the code. Okay. Good. Almost there, guys. Almost there. We have the run method. We have the predicate method. We have the callbacks. So now we only need the notify, the trigger, and the stop, and the start. And then we are done. So let's do this one by one. Notify. Let's move notify over there. So notify is a public function now. Yes. Yes, notify and trigger are public functions. So notify pub fn notify, and this just takes no arguments, and it does an self.condition notify all. Next one, trigger. Trigger, pub fn, trigger. This also takes self and nothing else. And this requires the lock. Let lock self mutex lock unwrap. And then we say lock dot triggered is true. Oh, it has to be mutable. Okay, trigger is ported to. Stop the stop function. Pub fn stop. So what does the stop function do? Again, we get a lock. And we say lock.stop is true. Then we drop the lock. Then we call notify. And then we call nano join or pass. Nano join or pass. I don't know what this function does. I guess it will just join the thread. It joins the thread if it is joinable. Otherwise it doesn't do anything. Okay. So the thread. We don't have the thread yet, so maybe let's just maybe port the run method first so that we know how, so that we do have the thread in Rust. So here's the start method. The start method, I meant, not the run method. So let's move the start method here. Pub fn start. So this does a debug assert that, oh, okay, I don't know how to port this yet. So let's start with the next line. So this runs a thread. I have to go to the documentation for this. Because I don't know this by heart. How to run the thread. Oh yeah, thread spawn. How could I forgot? So we have to call thread spawn. And this returns as a join handle, I think. Yeah. So this returns a join handle, and we can assign that to self. So let's make the self mutable, and let's assign self.thread is spawn. And in the spawn, we do these two lines. So we set the thread role name, and okay, yes, to set thread name, setting the thread name is different in Rust. You can't change, or I don't know if it is possible, but I think it's not. You can't change the thread name after the thread was spawned. So we have to use the thread builder like here. Thread builder new. So let's do it like that. Thread builder new. And then we can say name. So let's give it a name. And the name is nano thread role name backlog population. What is that name? Backlog population. What is that name? Get name, thread role name. Forrest says, unrelated, but would be cool to have nano tips with an attached message pop up on screen during live stream. Yeah, that would be really, really cool. I know Nautilus has a message feature in it actually. So yeah, so my plan is, as I said, like starting next Monday, I'm going to stream on Twitch and on YouTube. And yeah, so my plan is to integrate firstly the Twitch subscription messages like the other streamers do, and having a nano message, that would be so cool. And but this would require me to code it, I guess, and I don't want to waste time coding on stuff that is not so or otherwise. I think my time is best spent working on nano, and I could easily get lost coding fun stuff like that, and then the RS Nano project would not make progress. So maybe someone else from the community would do something like this. That would be so cool. Thread roll. Wenderson says DLive is a great software too. DLive, is this something like OBS? So I'm still learning all of this streaming stuff. Backlog population, thread name. Where's the backlog population thread name? Let's search for it. Backlog. There it is. It's just backlog with capital B. So the thread name is backlog. And why does this have to be an owned string? Oh, it has to be an owned string to owned. So we have the thread name, and in the thread we just call self.run. Oh, self, this captures a self. We have to redesign this, I think. Debug assert requires exclamation mark, and we assert not thread joinable. So that means not thread joinable means okay, that means our thread has to be an option. Our thread field. So thread has to be an option. Join handle. Oh, join handle is generic? Like this? Thread is none. Yeah, you're right, Forrest. So if someone sends a donation, I don't even. Oh, I got a donation. Oh, thanks. I got a 2 nano donation. That's great. Yeah, that's bad. Like people send donations and I don't even notice. Yeah, you're right. So we debug assert that thread joinable would be just thread dot self dot. So the thread should not run yet. So we debug assert that self dot thread is none. So there is no thread. When we call start, there shouldn't be a thread already. So that means we have to say this one is an option. So we turn this into sum. And arguments to this enum variant are incorrect. Tuple variant defined here. Oh, does this return an spawn returns a result join handle? Can spawn fail? Really? So let's just the normal thread spawn that doesn't fail, or does it? Thread spawn doesn't fail. No, it returns a join handle. And the thread builder, or what was what's the name? Thread. Let's unwrap it for now. That was too late. I wanted to unwrap in the spawn. So here, like that. And yes, so this self capture here is a problem. We can't do this. We can't capture self in the thread. So we have to move the run stuff into out of here. We have to move the run stuff out of here to Forrest says, I'm sure there are people in the community that would be interested in coding a tipping feature like that. Perhaps an idea for Nano Byte Pay. Yeah. Yeah, the Nano community has great developers, very capable developers. We can't capture self. We have to move the run method out of here. We have to move this to another struct. And this run method, it uses the mutex. Drew uses the mutex. Let's create a struct and let's call that struct backlog population thread. And then let's move the run method down there. And what else? Probably all methods I have to move. Oh, that was wrong. I have to say impl. Impl backlog population thread. And this now requires the mutex. And we have to move activate down there. Activate. And what else? Everything, I think. We have to move all of these functions down into the thread struct. Like this. And now we need the mutex and stats. So let's just copy these fields. Let's just copy all of them and remove the one that we don't need. So we need ledger, we need stats, do we need the callback? We need convar, we need everything. But not the join handle. Backlog population thread. Okay. Oh, I'm not sure if the callback, how would that work? Let's try. So in here, instead of calling self.run, let's create a backlog population thread instance. Thread. Let thread like this. And let's initialize all of the fields. So ledger, this is an arc. Yeah. So ledger, so we just clone self.ledger. Then stats is also an arc, so let's clone self.stats. Activate callback.
I'm skipping this now because I have to check how this is being used. So config, we can just copy the config, clone. That means we have to make it clonable. So let's derive clone. And mutex. Yeah, mutex, we have to change the mutex into an arc mutex because we, so into a, like in C++, this would be a shared pointer because we are going to use this mutex from our thread and from our backlog population instance. So arc new mutex new. So then we can also arc clone mutex. And the condition, oh, maybe we don't need the condition in the backlog population struct anymore. Can we delete this? No, we can't. No, we can't. So the condition, arc convar. So using a lot of arcs is not idiomatic Rust, but I want to get this to work first. So let's also clone the condition. And yes, activate callback. What to do about the activate callback? So the activate callback, can this be changed during the runtime? I think the activate callback is only being set before we start the thread. Let's see. Who sets the callback? Set callback. Searching for all usages. So there's a test which sets the callback. And this is, okay, this is after the start of the thread. And the node, it sets the callback here. And where's the start? Start method later. Okay, so the test sets the callback after the thread was started, and the node sets the callback before this thread is started. That means we have to support changing the callback after the thread was started. Oh, I don't like that. Because that means the callback has to be a mutex, protected by a mutex. And that's just, yeah. Yeah, but we have to make it work somehow, and we can optimize it later. So let's do it like that. So let's put the callback into a mutex. Into an arc mutex even. Arc mutex option. Oh, that's ugly. That's ugly. But yeah, as I said, I want to do one step after the other, so one step at a time. And my current step is getting that stuff to Rust. And the next step would be to cleaning it up. So I'm okay that it is ugly right now, and I'm going to clean it up later. So this is an arc mutex none. And whenever we set the callback, we have to now lock the callback mutex. And then we can set the lock to some callback. And in our thread struct, we have to change the condition also into an arc. Well, I forgot that before. And we have to change our callback into an arc mutex like that. So actually callback is arc clone self.callback. Activate callback. Mutex, we have a problem here. It says, what is mutex? Mutex is just a mutex? No, this has to be an arc mutex. Okay. Oh, this still captures, so let's move the construction of the thread out of the thread builder here to here, like this. And then we move this thread into the thread builder. And in there we say thread.run. Cannot be sent between threads safely. Send is not implemented for... Okay, send is not implemented for our callback. That's bad. So callback is a boxed in fn. So we have to say that this callback function has to be thread safe. That's why I like Rust. So Rust is very picky. So it says like this callback function, it could be not thread safe. So I have to say that this callback function is send and sync. So which means it's thread safe and it can be sent across threads. And same down here. So the activate callback. Oh no, I don't have to change anything here. So almost there, guys, almost there. Join or pass and self.notify. Oh yeah, stop has to take self. Okay. And join or pass means we have to join the handle. So that with self, so we have to take the join handle, so the self.thread that is. Take. If let some handle like this, we can now call handle dot join. It returns a result. Like this, maybe. Oh, I closed the file. I didn't want to close the file. Again, yeah, okay, here we are. Okay, so we have an error down here now, which says, oh yeah, the callback is It is a mutex now. We have to lock the mutex first before we can call. So this is now adding an inefficiency because we now lock a mutex when every time we call the activate callback. But I think this is not that bad because we don't call the activate callback a lot. So maybe this won't even hurt. So that callback lock is self.activate callback lock self.activate callback lock unwrap. And now we can match the callback lock. And this returns mutex guard option. Why doesn't it know what I want to do? Mismatch types, the full type name has been written to expected struct mutex guard. Mutex guard, do I have to say deref? Yes, that's the trick. So what else do we have to fix here? Cannot borrow self as mutable as it is behind a immutable reference. Yeah, okay, then let's make it mutable. What else? There's a problem here. Use of moved value lock. Value used after move. Luma Lagavlog says legend. Legend? Why? Lock. Lock is moved. Wait while. Oh, because it is dropped here. That's right. We have to reacquire the lock. Oh, that's good. Now we don't have any errors. We don't have any errors anymore. And I think we have now ported all of the class. So let's quickly add the FFI functions, so the C glue layer, that we can use them in the C++ side. And so this will be easy now. So we need a start, a stop, and a trigger, and a notify function. And that's it. So start, stop, trigger, notify. So let's do this. Oh no, what's that? There's errors here. Okay, this has to do. See what can be sent across thread safely. Yeah. So this is because our callback wrapper here. So now Rust says this is not thread safe because cvoid is not thread safe. So the solution to this problem is to create a struct that contains the cvoid, and we have to mark this struct as thread safe explicitly. What else does this capture? Just a callback. I want to try something quickly. Struct C void wrapper. It just has the pointer. And then we say impl send for C void wrapper. And impl sync. And this is unsafe, yes. No. And then let's add the context. What? No, what is the C void? This callback is not a C void. Oh, I'm okay. I'm getting lost. This callback has to be. This callback has to be send and sync. So we have to wrap. We have to wrap this callback into something, and then we have to say it is send and sync. So struct callback wrapper is a backlog population activate callback. And then we say impl unsafe impl send for callback wrapper and unsafe impl sync for callback wrapper. And then we put the callback into callback wrapper. And callback like this. And then we move the callback wrapper into our callback box. Where is it? Oh, down there. So we go into callback wrapper, callback. No method named. Oh yes, so this is a field, so I have to do it like that. Oh, that did not help. Send is not implemented for C void. Required for the cast from backlog population to 75, line 75. I'm stuck. You know what, chat? It's late. And I didn't get much sleep last night and the night before and the night before that. I say we call it a day. And with a fresh mind, I will have a look how we can figure this out the next time in the next stream. So we got really close finishing this class. So if we can fix this thread safety issue here in the next stream, we are done with the backlog population class almost. So because we just need these 4 small FFI functions, and then we can put them in here, and then we can delete all of the C++ code here, and then the class is completely ported to Rust. So that won't be difficult anymore. So the only difficult part left now is this thread stuff. And yeah, as I said, like I'm tired. I can't think anymore. So I want to call it a day. It was, again, it was great fun. So yeah, Jan says, I learned a lot today. Oh, cool. That's cool. Thank you. And
Yeah, so next stream is again on Monday. So as I said, I'm going to stream every Monday. So let's go to that screen so you can see. So I'm going to stream every Monday from now on and 7:30 London time. Next time we will finish this backlog population class and find something new to work on. And there will be a 5 nano giveaway, and I think a quiz again, because that was fun. Wenderson says, thank you for your time. Yeah, thank you guys for watching. Luma says, this is so cool, man. Oh, yeah, that makes me happy. Thanks for the bit. Yeah. So, yeah, if you haven't subscribed to the YouTube channel, please click subscribe. And that's it for today. Or do you guys have any questions left, or any suggestions, any ideas what we could do in the stream in the future? I thought maybe I could also merge pull requests, because Fiona, there's still a pull request from Fiona that I haven't merged yet. Or I thought about merging the upstream, so the original nanonode commits. But I thought that would be boring, because merging, it's mostly merge conflicts, and that would be just me fixing the merge conflicts. And yeah, I think that would be a bit boring, maybe. So if you have good ideas, please let me know. Write it as a comment or write it in chat. Yeah, so yeah, let's call this a day. It was great fun. Happy Valentine's. Happy Valentine's, chat. Yeah. Oh, I have to get something for my girlfriend still. But there's still time. Don't forget to mention your Twitch handle. So, oh yeah, my Twitch handle is the same as my YouTube handle. You can see it up here. I put it up here already. So it's G Schauwecker. And yeah, next time the stream will be on Twitch too. Okay, guys. See you soon. Bye.